Welcome back after the lunch break. I hope you enjoyed it. I'm happy to introduce Milan Gabor now, who is telling us how to visualize Wi-Fi packets the hacker way.
Okay. Hi, everybody. I hope you're fine after lunch. So, what? In a mood for sleep? Or not? Or you're still alive? Come on. Still alive? Yeah, that's his mood. Okay. Let's start. Who am I? Actually, I'm for the second time now at the DeepSec last year. I was also speaking last year. This year I had a problem. Why? Because I got accepted at the two conferences that were running at the same time, so DeepSec and DevCamp. So I have to decide which one to go. So I sent one of my guys to the Bucharest, and I joined here for the DeepSec. And I'm really glad to be there, glad to be here again. So I'm certified ethical hacker, if this means something. And beside that, I really like to fly the drones. Does anybody flying a drone already? Okay, 2, 3, great. Do you have any idea why the drones and Wi-Fi bind really good together?
Yes.
Why?
Because they're transmitting the video signals.
Yeah, video signals, but also you can go in places where normally you cannot go. You know, you can fly over the companies, you can fly over the, let's say, botschafts here, French, you know, English, yesterday that we've seen, so you can make really good pictures and even sniff the Wi-Fi packets with your drones for more than a mile away, so nobody sees you, you know. So just a short reminder about last year. Last year we have been playing with the mobile application, so it's still up there on the GitHub if somebody wants to use it. So that was last year. And this year we are playing with the Wi-Fi packets. So, but before we start, let's make some deal. Since I will be playing with Wi-Fi packets, so if anybody has a problem with it, please turn off your Wi-Fi now. But this means also that we won't have so much fun. So if you want to have fun, just leave your Wi-Fi on, and I will start. I guess you all know this kind of really popular tool, and you're going to see what's actually capable of. Do you agree on these terms? Is it fine or no? But the problem is, you know, you agreed. But what's the problem with Wi-Fi? The guys in the next room, they didn't agree. But we will still see their packets. And also from the guests from the hotel. So we're going to talk about it today. I tried to put this into a SQL sentence. So we're going to be inserting into Elasticsearch, elk stack. So Elasticsearch log section Kibana values. So values from the dumping the Wi-Fi packets. And we're going to search a little bit. We're going to we won't be modifying it, but we will try to look for strange patterns. Maybe see who is drinking tea with somebody, or at least we will try to get some phones. And we will get definitely some crazy ideas at the end. So this is for agenda. So where's the problem? So does anybody recognize what this is? Spectrum of Wi-Fi, right? But Wi-Fi can be really, really interesting, you know? Why? When is the last time you have seen your wireless packets coming out of your phone? Have you met him? Have you met your wireless packets? When was the last time you checked what's actually your phones, tablets, and even PCs, notebooks are sending out? When was the last time? Anyone?
1 week ago.
1 week ago?
Yeah.
What did you see?
I don't know, connect on my Google phone connections to Google.
Yeah?
Another.
And that's it, only connections. But it's sending really, really nice stuff you're going to see. And if you do some magic with it, you can get really good results out of it. So actually what we're going to try, You're familiar with that, right? With aircrack NG tools, who never saw this kind of screen yet? I guess that's crazy question to ask at a security conference, right? But we're gonna try to put this kind of data into this. So you're gonna see really quick, try to see what's actually happening in the air at that moment or in the present. So actually we are dealing with the big data. Why? Because with this, you can get only a text, some fields, and you don't, if you're just grabbing them into, I don't know, XML or some other format, CSV, then you don't have any history. You don't see when the phone was on, when it was off, it was moving away from you, or it was getting closer, what kind of packets did they send. So you don't see this. So that's why you need some storage. And searching over the big data, and we found a really good solution that's called ELK. We're gonna go very quick through it. But if you have the big data, so a large amount of data, and you don't know what to look for, and you don't know how to extract it, or you don't know how to use it, it's useless, right? So if you have like 10 terabytes of data and you don't know what to do with it, is it useful or useless? Useless. That's why we're going to create some really nice, let's say grabs that you can do it also on Monday when you get back to work, get back to your research labs, or get back home. So that is my goal for today. But before that, let's just jump into reality. What kind of the stuff we have? This one we see. So we have this. If I go to my Kali, so this is what I see at the moment regarding the Wi-Fi packet. So I see the access points, I see the probes, I see the clients, I see who's connected to where, what kind of encryption are they using, what kind of channels. This is what we get from output from aircraft. There's one tool, actually from a guy that you probably know, Vivek Ramachandran, something like that. I don't know if it's right pronunciation. It's a tool that you can actually get PCAP, put it into tool, and it spits out something like that, and it's actually in a SQLite database. But it's not so much fun to play with it. We tried it, but it didn't work for us, so we tried another way. So it actually was a challenge for us. And everything started this year when we organized Capture the Flag for B-sites in Ljubljana for the first time this year. And we had problems since we were organizer, the Capture the Flag. We didn't know what actually attackers are doing on Capture the Flag servers. So we were start playing with ELK. So we put all the logs. We tried to see where are actually, did they already crack the machine, or they're just guessing the passwords. And we saw that we can use the ELK stack also on different ways. So just put a large amount of Wi-Fi packets into and see what will come out. And this you can do without writing single line of code. How many programmers are here? Okay. Would it be nice to have a tool that you don't need to program something? Great, right? You're a developer or sysadmin or DevOps? Both. Okay. So without writing single line of code, you will see that it's possible. But where do we start? So, any guesses? Where do we start? What do we need? What? Data, okay. Anything else? Analyzing, yes. But mostly we can do two things. We need a hardware, we need a software, right? It's the same. So what kind of hardware do we need? Definitely you need a wireless card for capturing the packets. You can buy this really, really expensive Alpha card, which costs around 40 euros, something like that, you know. With this, you can do really, really good picture capturing. But it's not one card. If you want to be really successful, you need more cards. Why? Because if you use one card, you're going to be just hopping the channels. You won't see any packets. So if you like 3 or 4, maybe 5 wireless cards, then you cover almost all the spectrum and you get even better data. Definitely US cables, let's say power, and a big screen. You're gonna see, but because if you use Kibana, if you try to do on this resolution that I'm gonna be torturing myself in like 50 minutes, then you have a problem, because you see that the graphs and everything is kind of small, tied in. So you need a big screen, or at least 2 screens if you're out. So what's regarding the software, you need your favorite operating system. A lot of people are on Mac, so if you use Mac, it's fine. I use Linux, it's also fine to use Windows. But you need to keep in mind that some of the components will get you some challenges, especially if you're using Raspberry Pi as one of the hardware components. Okay, so again, we need a hardware, we need a software, and we need 2 things. So first we need an environment where to put all this data, and the second is the data. So if we start building our blocks, for environment, definitely Elk Stack. Who is using Elk Stack? I know Josh is using it for his honeypots because we have been witnessing yesterday. It's a great tool. Who? Can you raise your hands again? Okay. What do you think about Elk? Yes? Yes? 2 thumbs? Yes or no? Or cool. Okay, so Elk Stack, for those that who doesn't know what that's, it's actually this kind of dashboards you can build on, visualize with Kibana. So you can do like, people are doing really crazy stuff. Not just honeypots, also log analysis, CM systems, what else? Network operations centers they have built on this stack. But mainly, what kind of 3 components you have? You have Logstash, so you have your log shippers, or Logstash server, or here you have Logstash forwarder. Then you have, on central point, you have Logstash server, which does all the kind of magic. You have the storage, so indexer storage with Elasticsearch, and then you have Kibana as a GUI for that. So Logstash is doing really great stuff with parsing, collecting, modifying, transporting, and it's really easy. For example, this is the configuration that I'm using for analyzing this. So it's like roughly 25, 30 lines of code, configuration file. For the Logstash, it's actually doing some stuff. So you see I'm reading the logs. I'm actually doing some kind of transformation with some data, and I'm writing it to the Elasticsearch. There's also called Logstash forwarder, because you don't want to run Logstash server on each instance, but you need only for collector or for a sensor. But you might run into some kind of challenges, especially if you're using Raspberry Pi, because the Logstash forwarder is built into using Go. And Milan says about the Elasticsearch, searching Elasticsearch string for country like Austria, you see that there are 16 instances of Elasticsearch open to the whole internet without any authentication. Do you think you can find some interesting data in this Elasticsearch indexes? Yes? Who votes for yes? Okay, 1, 2. I try with 1, but so you get the treatment title, osteopathy, electrotherapy, therapy, massage, Bewegungstherapie, taping, count, and if I would screenshot also here details, you will get the actually real persons from Austria having sessions with their doctors. So you see the patient here, patient name somewhere here, and also the doctor who's taking care. And this can be found on Elasticsearch databases. But Elasticsearch is not a problem. The Mongo, it's even a huge one. So we have some issues. And we have some other issues with the Elk stack. First, as I told you, it's actually, if you configure from the scratch, there is no security. So you can buy it now, but you have to pay, of course. And there's a problem if you want to have like monitoring tool or CM system built on it with alerting. Of course, you have to buy it. It's under constant development, and there are some big changes between 3 and 4, and still some of functionalities that I'm going to talk at the end is still missing. So the second thing, so we have the environment. So we built an environment. The second thing, it's the data. So if we go back here, you see, can we put this data into Elasticsearch and expect it to be working? What do you think? Yes or no? Would it? Huh? Really? Well, if you're talking about Elasticsearch, we speak about some strange data format like JSON, you know. Then with this, we have a problem, because this is not the JSON. So Aircrack doesn't speak any JSON. It doesn't spit out any JSON. We tried a lot of things, you know, to parse output, to parse CSV files and nothing. And then we tried to change the code. That's why it's really open source is good. So we got the source code and we change it, modify it, and we are still thinking to contribute back to the main branch. So you get a JSON output of the Aircrack NG. So we did two changes, mainly. First, I don't know why it changed with, I think, latest 2 versions. This is one parameter. It says number of probes. So probes are actually packets that your phones are sending out and asking for the wireless networks around you. This is, in original source, it's set to 10. So it's really low. You're going to see that most of the phones are sending even, I don't know, 50 or even 150 probes. So that was the first change. And the second change, we actually wrote the functionality dump JSON. So we are getting this kind of data out of Aircrack. Can we put this into Elk Stack or Elasticsearch? What do you think? This one looks much better. It is JSON style. Should be, right? So we got the environment, we got the data, and then we should start somewhere, right? But the starting, it's always the hardest thing to do. But now it's demo time. So you like the demos? You want to see what's actually has been collected in the last 15 minutes of my time? Are you ready for the moment of truth? To see where you have been. Where you have, I don't know, had lunch last week, you know? Or maybe with who you're hanging together on the Wi-Fi networks. Oh, let's start here. Oh, not this one, this one. So when you start with Kibana, you get something like this, you know. So you have your input. So this is kind of JSON style, which is parsed. And you see that this one is, let me see, which one is, Station Mac. So this one is coming packets from one mobile phone. It's actually produced by Shenzhen Technologies, or at least they have the MAC address that belongs to them. And it's actually connected to Renaissance guests, Wi-Fi, or at least speaking out that's wanted to be there. So this is the first thing that you have. So you have large amount of data. So if since yesterday, 3 Spanish guys told me that if you don't do live demos, you're pussy. You know? So, I couldn't record this, so I was already sniffing the packet. So you see from today, there's amount of data. So I have like 1.6 million entries. So 1.6 million of analyzed data already inside. And this is the data that has been analyzed for the last 15 minutes. So we see now the packets are still rising up. So this is actually our input. But is this fun to read through? If you have like 36,000 packets, 36,000 records now. But Kibana offers really good stuff. So you can do like this, With this data, you can have this. So let's try to explain a little bit. Do you see in the backline, in the last order, or should I make it bigger? Or or let's try this. Now you see my, okay, so I created already some kind of dashboard. So you see the Wi-Fi with the strongest signal. So what does this mean? So this means that I see which one access points are really close to me, so with their power. And you see that they're falling down. So you see the conference and the Wi-Fi 6, BV, Safu, Yana. So we are catching also the wireless access points around, maybe from your phones, maybe from around, from next room beside us. Then we really quick see what kind of the encryption types they're using. So you see that mainly it's open. So because a lot of wireless access points in the hotels are open, VPA, VPA2. And here you see that I have my card. Have seen, so 169 unique BSSID and 300 clients. So 300 phones or tablets or notebooks around me since last couple of minutes. Then let's go on. Let's see what kind of vendors are around us. So you see that Ruckus Wireless is leading because the hotel is using the Ruckus Wi-Fi hot access points. So for the guys from Spain, you know, if you want to try to play, you know, Ruckus, maybe some management access points. So you see really quick. Then you have Netgear, you have router board, you have Fortinet, Huawei. I guess this is probably some hotspots, mobile access points from users. And then you see also what kind of the types of the phones you have. So you see Apple is still leading, or not. But it's interesting because if you calculate also Apple against the other, Apple is losing. But you see that there are some Intel phones, Samsung is quite high, Sony, LG, stuff like that. And then comes the real interesting point, you know. So okay, we know that there are Apples and other devices, but here in the next graph we see the top probes. So the probes are actually sent out by your phones, and if we try to, oh, now we will have a problem because it's really low resolution. But let's try to find if somebody recognizes his phone. So you see that this one, it has been connected to Danielle, Besucher, Tele2, Freeland, Belking, blah, 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 iPad. This one has been connected to MyCloud, Desun, Psy router. Löwe, Linde, Legoland. So I know that guy has been to Legoland. I don't know him. I don't know what kind of his business, but I know he has been to Legoland. But let's see if we can try to find what kind of a phone was he using. So we just filter on his station MAC ID, and it says that it was Sony. So I already know what kind of phone. So if I go around and see, oh, you're Sony, I can eliminate you already. So okay, so he has been to the Legoland, so okay, and he's using the Sony phone, and I guess probably with some more probes that actually could be queried, I could do something like this. I was playing already before because I didn't know what kind of packets would you get. I saw that somebody around here has been using iron cell or beaconing out iron cell, and if we try to map this, on a map, we see that actually this guy was moving around Iran somewhere at some time. And he has been really close to me this day. So this is the missing functionality that we are still missing from Kibana because you cannot do connected links. So if I want to see, let's see, show me who was on that and connected with this kind of tool that I can get the location. This is still the missing functionality, the missing piece. But we are working on it, so I guess next couple of months, hopefully we will also have this kind of solution. But let's try to see if somebody else is, oh, now it's even better. No, okay. better, let's see, Besucher Schnitzelhaus public. Oh, so we know that he's like schnitzels. MetaLab. Oh, okay, so they're hackers. Yay, Cookie Monster, I like cookies. Popsu, does anybody know whose phone is that? Or recognize himself? Galleria Gäste McDonald's, okay, I know he's using it McDonald's. He's using the Thalia V3, Tower Renaissance. So it's a lot of things that you can learn from these packets and visualize and see it quick. So if you would go with Aircrack NG and your Kali Linux and text console, you wouldn't see that. Maybe if you have like an eagle, then you would see that, but otherwise no. Then the next thing is, let's see if we can manage to get who is actually hanging together with whom. So on next graph or next data, we see that we try to group together the phones who are beaconing out the same Wi-Fi access points that they have been connected. Okay, for Renaissance guests, there are a lot of people staying in this hotel. DeepSec also, okay, presenters, this is for network for us. But then at the end, change SSID, Cart Echo, Olympus, Kuvulan, Schlosspark, or Belkin, or D-Link, maybe some kind of unique IDs. You see that, for example, which one? Cart Echo, you see that there have been two people, or at least one person with two devices, that they have been together sometimes, connected sometimes at some I don't know, maybe years, maybe months, maybe days, maybe hours, before on that same SSID. You see, and we can also see who is grouping together with him. So Kibana offers really easy. So if you want to see who was on Olympus together, let's say I have now two different phones. You see, this one is one phone, and this one the other phone. I could do then again with client access points and play it and go deep down without touching any code or doing the programming. Okay. And then you have kind of like access points and the client stream. So this is actually refreshing at every refresh interval. What kind of the data is coming in. So you see that you have Wi-Fi access points that is open here, and then it's on channel 1, and you have the power of the Wi-Fi, so you know it's closer, it's very far away, and the manufacturer of this access point. It's the same with the clients. And with the clients, it's also, you can count the packets. So if you're sniffing out, you see who's actually really active on the net, who is not doing anything. You see that this one, DeepSec 2, who's actually beaking out, was quite active. So you see a lot of stuff. And you can also do this kind of, you see the packets, you see the clients on Wi-Fi. So you see how, this one, if we are going for 1405, when we started, you see that I'm getting more and more packets. So I see that on DeepSec, at the moment, for latest data, it's like 19 different devices on a DeepSec Wi-Fi. And then it's getting even more interesting. Can anybody guess what this kind of representation of the data, this Wi-Fi data is? Let's see who is connected to DeepSec 2. So we have ESSID DeepSec 2. So we see that DeepSec 2 has two physical access points because it has two BSS IDs. So this is the first MAC ID for DeepSec. This is the second MAC ID for DeepSec. So we have ESID, BSSID, and these are the MAC addresses of the phones. So I know that, let's say, this phone with this MAC address produced by HTAC, it's actually connected to the DeepSec 2 on this wireless access point. And this can do for every data that we see. So if we want to just filter out for the DeepSec 2, then we get all the data only for the DeepSec 2. DeepSec 2, the ESSID. And we can do also some other interesting stuff. Let me see one. Let's try to load one. Visualize channels density. See, you can also do, if you're a sysadmin, with this you can see which kind of channels are very, very occupied. You see that channel 1, I wouldn't set my Wi-Fi on channel 1, 6, or 11. And these kind of the Wi-Fi are even less occupied. And it's really easy to build this kind of graphs. So, since my time is almost, not yet? No, I still have some stuff. I can show the demos next hour. So. No, but definitely there are problems. If you're building this, then definitely there are some kind of problems. One problem is, but it's not only the Elasticsearch problem, but also problem of entire, let's say, InfoSec community. It's Java. Why? Elasticsearch or not? Yes? How much your stack has RAM given to the Elasticsearch?
16 gigs.
16 gigs. Okay, 16 gigs. Somebody has more than 16 gigs for Elasticsearch? No? No? Mine? How much? So it's a problem. Or it might be not the problem because you can run it on Raspberry Pi, the whole Alex stack. And I will show you that also I've been running it now for the last 15 minutes on my Raspberry Pi that's actually sitting here. I don't know if you can see it. So it's Raspberry Pi, it's TP-Link, and it's power bank, so it's powered on, and I have connected to my computer, and it's running. It's running. Let's see if it's still running. So this is coming. So this is coming from my Raspberry Pi. You see that if we try to connect to my Raspberry Pi, you're going to see that it's really under. It's really too fast. Work, yeah. And we try to see if what is actually the load of my Raspberry Pi, or it's sweating. You see that it's quite 13 load average. You see the 185% CPUs. So all the cores are quite busy, which is good. But it takes some time to get the data from the Alex stack. But you have, you just bring your Raspberry Pi, walk around the conference, sniff the data, just walk out, You don't have to bring your computer, you don't have to bring your big antenna, but it takes quite some time. But here's also idea that Raspberry Pi can be used only as a sensor. So you just run aircraft or aero dump on it, and it sends all the data to the Josh stack, somewhere Alex stack with 32 gigs of RAM, which will do all the rest of the work. But you see, we got the data, so you see the only problem is that Raspberry Pi has some problems with the time. So it's not connected to the internet. So the timestamps are not quite, let's say, accurate. But you can still use it. So it's gonna, in some time, it's gonna also show, the same dashboards actually running on my Raspberry Pi. So for this quick, let's say, evaluation, or if you're going somewhere on a mission, or you're just trying to see what's around the clients or targets, or maybe even what kind of the phones are your neighbors using, connecting to their Wi-Fi. You see, okay, they're using Apples. So, this is going to take so little time. Before end, there are definitely different kind of usage for this kind of, let's say, stack or Wi-Fi. Wi-Fi packets. Definitely we can use it for penetration testing or security audits. We can use it as a CM, so you see what's actually going on around your Wi-Fi networks, or you can do it with your graph. You know, if you know that you have only 20 employees connecting to the Wi-Fi, and suddenly you get like 50 clients on your Wi-Fi network. Definitely for intelligence gathering. So you see that, you know, if you're taking, if you're gathering this large amount of Wi-Fi packets, you can really track down or even monitor people where they're moving. We have been playing if we could see that actually person is moving around the room. So because of the power that's transmitting, but this was not quite successful. The other ideas are tracking the stolen phones, or maybe some kind of traffic records of open networks, building the huge database. I know we have been playing, we are just monitoring the probes sending out from the people that are driving on the road beside our corporate building. And we got in 1 week like several millions of records for different kind of things. So it can be really interesting. See, my Raspberry Pi is still sweating. So it's gonna finish sometime soon with nice graphs. But there are also some kind of other crazy ideas which are not very appropriate for public talking. So since I don't drink, you can buy me a Coca-Cola afterwards, and we can discuss it a little bit later. I know I have been discussing with yesterday at the dinner and yesterday at the lunch already with some of them, but definitely you can get some crazy ideas. So if you want to play with this, on our GitHub, we already published a patch for the latest version of Aircrack NG. So if you want to play with Aircrack, so to dump all the JSON output, just get it. It's not very, let's say, it's easy to build your version. If you have problems, just send me email. Let's see, before we end up now, it's still working. Still working, so. Okay.
Yeah, please release the JSON or the JSON patch, or send the patch to the developers of Aircrack.
Yeah, we will do. That's our plan.
That's really cool.
It's at the moment we put it on the GitHub, but we will do it. We will send it to the developers. So might be the sure. But since we are not the coders, you know, it was more than hacking, so it needs code a little bit cleaning up, tidying up. So.
How much configuration do you need to get to this point? When you start from scratch, how many hours would you say are needed for these results?
I did it this week with the latest version of Elasticsearch. It took me like, on the Raspberry Pi, it took me like 3 hours. If you have a virtual machine, I'm running Elk Stack. It perfectly runs also on Kali Linux. So you just download the dev.bm packages, and there are no problems at all. So you can run it on your and just stop it. But be careful, because it can eat a lot of RAM. So if you put it into startup scripts, then you have a problem. But you just start it when you need it. But let's say 3 days. But for the first time, because you will get into some kind of issues, it will take like 1 day for whole setup of everything. So building the Aircrack, patching it, building it, setting up the Elk Stack, connecting it together, and running the queries. So I can share also the Kibana dashboards. So if you need it, so you don't have to build on your own. Or maybe we should put it on our GitHub. So, but if you just tweet me, and I will try to help you. It's not a problem. So.
Sorry, you mentioned the number of Wi-Fi cards. Did
Yeah.
you experience any troubles in using just one?
No,
Thanks.
no. That's actually that scanning. It's done by one card. This morning I've been running with 4 cards on different channels, so I get as much packets as I could. But one card it's also fine. But I prefer alphas because it has it can bring out the more power, and you can get much more packets than with normal or internal packets. But it will do with any cards that's supported by aircraft engine. So.
Well then, if there are no more questions, thank you.
Sure. I hope you enjoyed it.